Okay, so the concept that we are going to look into now is what we mean by r-Radix FFT. Generally, that's how we define FFT. Is the most common one. Before even we get into the discussion, is 2-Radix FFT. So sometimes in books it's written the 2-Radix FFT of xn is this. So then people wonder, what do we mean by 2-Radix? So we'll just talk in general about r-Radix, and 2-Radix happens to be one of the special cases. So suppose one needs to evaluate endpoint DFT. Okay. Furthermore, suppose that n can be factored into certain smaller sections such that I can write n as r1 multiplied by r2 multiplied by r3, so on up to rn. In general, these sections are of unequal length. That's why I'm writing them as r1, r2, r3. But probably the most convenient case is arrived at if I consider r1 same as r2, same as r3 in terms of length, and rm equal to r. If I do that, then I get n is equal to r to the power m. For example, suppose I say that you have to calculate a 8-point DFT. So I can write 8 as 2 to the power 3, right? So in this case, your r is 2, your m is 3, right? Suppose I have, let's say, n is 16. Then I can write 16 as 2 to the power 4. So r is 2, m is 4. Suppose I say that n is 9, and I can write 9 as 3 square. So r is 3 and m is 2. Okay. Just simple calculation based on the formula that I wrote in the previous slide, this one. This fundamentally tells me something, and that is that this r is the radix of the FFT algorithm. Of FFT algorithm. And this number m or quantity m is the stages in FFT algorithm. Now the question arises, what do we mean by stages? But before that, I can call, suppose this FFT that this DFT that I'm evaluating for n equal to 8, I can call this as 2-Radix FFT with 3 stages. N equal to 16, when I'm writing it as 2 to the power 4, I can call this 2-Radix FFT with 4 stages. N equal to 9, I can call this as 3-Radix or Radix 3 FFT with 2 stages. Right, so this is pretty straightforward. Whatever is written as base becomes the radix, and whatever is written as the exponent becomes the number of stages. The question is, what do you mean by the number of stages? So let me just give you, suppose we evaluate endpoint DFT and let it be a 2 radix FFT algorithm that we use for evaluation. Well, what does this mean? This means that divide endpoint DFT to 2 equal n by 2 point endpoints n by 2 points DFT. Then divide each of n by 2 points DFTs to 2 equal n by 4 points DFT, and continue this process till you are left with evaluating 2-point DFTs. So the number of times you have to divide will give you the value of m. For example, suppose I say that n is equal to 8. So n is equal to 8 means that you have 8 points. You have to evaluate 8-point DFT. So you will break this into n by 2, which means 8 by 2 point DFTs. They may not look the same, the rectangles I mean, but that is basically what I mean, point DFT, which fundamentally means 4 points here and 4 points here. Then each of these will be divided into 8 by 4. 8 by 4. This is fundamentally the breakage is here, and for here the breakage is here, right? So this is one demarcation, this is the second demarcation, and then you have 8 by 4 here, 8 by 4 here. So this is fundamentally 2. So stage 1 you could call it, stage 2 you could call it, and stage 3, because now we get values 2, 2, 2 and 2, we stop. and you can see that we can write this 8 as 2 to the power 3, where 2, which is the base, is the radix and 3 are the number of stages. That is basically what I mean by radix and the number of stages. Suppose we had n equal to, suppose we had n equal to, just a second, yeah. Suppose we had n equal to 9. Then I can write 9 as 3 power 2. That means this fundamentally becomes a 3 radix FFT with 2 stages, because R becomes equal to 3, M becomes equal to 2. So this would look something like this. So you have 9 points here. Now these 9 points could be divided into 3 equal halves, n by 3, n by 3, n by 3, and let's demarcate them like this. So this is 3, this is 3, and this is 3. So this is stage 1, the inputs coming from here, the outputs coming here. We'll see what these are, and these are the inputs coming here. 3, here you'll have 3, here you have 3, and this will be the stage 2.